Hello and welcome to another webinar session on Industry 4.0. So thank you guys for joining the webinar today. My name is Abhishek and I'm part of the marketing and sales team at Factana. So today's webinar, we are focusing on asset condition monitoring for oil and gas. So as always, let me begin with an introduction. So Factana is the cognitive IoT company specialized in providing IoT-based Industry 4.0 solutions to small, medium, and large enterprises. So we are based in Bangalore, India, and Illinois, USA. As part of our Industry 4.0 offerings, we are the providers of Fogwing Industrial IoT Platform, which is the no-code IoT platform with an inbuilt advanced IoT data analytics studio for data visualization and better decision making. Along with the Fogwing platform, we are also providing SaaS-based industrial IoT solutions called Fogwing Eco, Sfactrix, and Fogwing Asset Plus. The Fogwing Eco is the plug-and-play industrial air pollution monitoring solution. Sfactrix is the smart manufacturing solution for industrial enterprises. And Fogwing Asset Plus is our upcoming AI-powered asset condition monitoring solution. So the webinar will be presented by the founder and chief of Factana, Mr. Hariharan Ganesh. So without further wasting time, let's jump into the webinar. So Hari, over to you.
Thank you, Abhishek. Hello, everyone. Good afternoon, good evening, good morning, wherever you are watching this webinar, or later you are watching in our YouTube channel. We are here to talk about asset condition monitoring for the oil and gas industry. Explicitly for oil and gas industry, one of the key business that required such a solution for monitoring machineries. So before getting to that, let's have some common understanding about asset condition monitoring. Is it one hardware deployment, or is it a software deployment, or is it a kind of one-time connecting to machines using IoT and then done? It's not like that. So asset condition monitoring is a continuous process. The process of monitoring the health of the machineries and taking actions based on the monitoring inputs, based on the health conditions, from various stage and steps to follow and identify the patterns to improve that into a mature state. So the state from traditionally the machine maintenance starts from more of a preventive maintenance, which are high operational cost, because without understanding the need of that, there is a scheduled window of maintenance activities that ongoing actually conducted by the maintenance engineers. So obviously, without knowing the need of that, there is a maintenance activities done. That obviously increase the cost of the maintenance activities. From there, we are going to take the organization into more of mature way based on the prediction. The prediction is based on the usage of the machines, based on the condition of the machine, based on the performance of the equipments. So it's based on the utilization, based on performance and other mechanical, technical parameters. So based on that, we create predictions. Based on the predictions, we do the maintenance instead of doing a schedule-based maintenance. So that would reduce the operational cost for the organization instead of doing a repetitive process when and where the need of maintenance that will be executed as per the prediction. So the process is to take from preventive maintenance model to the predictive maintenance model with the help of the ACM, also called as asset condition monitoring. So generally it's a process. So we need to go step by step to understand how we are going to drive that into the prediction and even further beyond that. So today in this webinar, we are going to see how the asset condition monitoring solution or process helpful for the oil and gas industries, especially, and also how this can be taken up and implemented on a step-by-step strategy. So before getting to that strategy, let's understand the oil and gas industry operations and equipments, because this is very critical, right? Asset condition monitoring or machine condition monitoring is all about machineries that we are using in the factories, either a traditional factory or it's oil and gas production setup. So there is a different set of machineries are involved on that. So one is, we basically start from that. So there is a 3 stage of operation happens in the oil and gas industry. The upstream, basically where the pumping station is there, or the source of the oil and gas. So that being pumped out and then pushed into the containers or storage or pipelines, which is called midstream, basically carrying that oil or gas content to the factory setup. And then downstream is basically the purification system or the factory setup where the oil purified, refined, and then the gas are filtered and then containerized and then getting into the retail market. So that's a downstream. So basically from upstream, midstream, and downstream, there are various type of equipments used in the oil and gas industry, from wellhead and pumps to the storage container, the air pumping systems, the media chemical pumping systems, which are more like the chemicals like a liquid form or solid form or sand format of chemicals that is coming out of the well, and those things are flushing out, and those kind of machineries involved on that. Heavy equipments are involved on that. On the midstream, of course, the pipelines, the storage pipelines, the pressure of the pipelines, the tanks that carry forward that gas or oil, or how the pressure is maintained on that, and various compressors, pressure meters used to monitor that, right, or to measure the level of pressure maintained on the pipelines. And then down the line, the production and test manifold, the production separator, which basically separating the oil, different level of oils from the crude oil, and then how they are all filtered, stored, and then distributed to the retail supply chains and other things. So all of there, there are a lot of equipments, heavy equipments are involved, and all these equipments are in a extreme condition where it has to continuously, constantly running. So that requires a lot of maintenance activities. So typically oil and gas industries, the engineers carry forward the proactive and or preventive maintenance, which basically with they put it in a schedule, and then they continuously go and check the condition of the equipments, machineries, and then do the operations. So this is significantly increasing the cost. But also understanding that the remote places where the machineries are deployed, right? There are various conditions of the machineries that are environment conditions that could cause the machines to go into failure. Any failure into those machineries, it's a significant impact on the pipe supply chain of the oil and gas. So that will also impact the price of the market, right? So it has a multifold of impact from the operational to all the way to the consumer consumption aspect of that. So generally, to understand what are the different variations are there on in terms of the environment climate condition that impacts the operations. The first thing is the machine operations. A lot of heavy equipments are there, and pumping systems are there, and they're all working on different climate conditions or the earth conditions. So there will be a huge vibration and frictions happening on the pistons level or the motor level and all the stuff, based on the pressure maintained in the earth level and then the pipeline level. So there is a lot of vibration is getting created. These vibrations could create a problem, frictions, and those frictions will lead into a degradation of the equipments that obviously go into the failure mode or downtime situations. So that has to be prevented. Second thing is the high temperature. Obviously, these environments are highly high temperature created by the gas and fumes, and which required extreme care of materials that used in the field, right? So high temperature is created, more than 500 Fahrenheit of temperature should be created. The equipment should withstand on that to run that. Third most one is the high pressure. The pressure is extremely high because of the gas formation, the pressure maintained at the oil flow level as well as the pipeline level, which required significant withstanding effort by the equipments, and depends on the conditions it has to maintain it, because different remote field equipments have a different climate conditions above the earth and below the earth. So it has to stand on all of them, and there is a high possibility of these pressures could create a problem on the machineries. The chemicals created by the gas fumes, or the chemicals coming out of those pipelines, right? Those could create a problem on the environment, or as well as on the metals or the materials that being deployed on the field. So that could also create a lot of problem in the machineries that being operated on the remote. The corrosions, like because of the salt and materials, the water level, the sand type of sand that being used, and dusty pollution environment, that also creating a lot of material degrade on that due to corrosions and other things. Overall, by managing all of this and constantly putting effort to maintaining the materials and the machineries and their conditions, is important to constantly producing a better productivity. But obviously that is going to impact the huge cost of materials, because constantly we are replacing materials based on the preventive maintenance aspect of that instead of predictive. So we need to move. So this is a very common or most applicable environment where we should apply the asset condition monitoring based solutions, which basically constantly monitoring the asset condition, health condition of the machines, and then moving them from where it is in today as a preventive maintenance to the more predictable maintenance activities to reduce the operational cost, at the same time to maintain the availability of the machineries. So to strengthen this theory, right, there was a survey which conducted by the Daily Oil Bulletin Board, and they have identified that more than 49% of operational costs spent by oil and gas industry are related to the maintenance and repairs of those machineries. So explicitly 50% of the cost, almost 50% of the cost that they are spending on their operational cost, they are spending on the maintenance of the machineries, which is a significant cost for them. So anything that help them to reduce the maintenance effort and operational cost in managing those equipments or managing the components replacement, other things, so that will help them to reduce the cost and also increase the profitability. So always, industries, all the, like, based on the surveys, all the industry leaders in the oil and gas in the space are, intend to reduce the maintenance cost as always. Right, so this is very important piece that even the industry owners are agreeing that that is something we should work on that. So obviously the result is, how do we reduce the maintenance effort, right? So why maintenance is happening, right? Maintenance is happening because we are trying to prevent the failure of the machineries, right? The failure of the machineries obviously resulted in production stop, and then obviously result in pipeline the revenue loss, right? So so how do we execute the more reactive or preventive maintenance activities? How do we move that into more of predictive maintenance, right? So to understand this process, there is a methodology. The way to understand this, there is a methodology provided by ISA it's called a PF curve, which help us to understand what are the various state of the machine conditions, and then how we can measure different state of the conditions and then how do we identify the state where we have to maintain the machineries without impacting the operational cost as well as the production activities. So here, if you look at in the chart, right, the curve chart, it starts from failure, right? From the failure, how do we identify the before failure, right? The worst condition is the mechanical failure or electrical failure. That could be possible. And then when before that mechanical electrical failure happens, there could be some indication in the machine level. Either the machine may be too noisy if it's a mechanical failure, or it may be a electrical failure that may be creating some fumes, electrical fumes, or the fumes that because of the burning cables and other things. So that creates some kind of a smell or heat, right? So before the failure happens, there could be a possibility of a noise, there could be a possibility of heat and smell, right? So if we have a way to identify that, then we could avoid the mechanical or electrical failure happening on the machineries. Now, before that, right, this is more reactive, right? So of course, noise is coming, then only we are going to react to that. Before that, we can also prevent it. Before the noise is coming, what could have happened? Before the noise coming in the machineries, mechanical or electrical, right, that could be a possibility of vibration. So vibration is one of the key things that we should talk today, because vibration is one of the key parameter that can help us to understand the machine conditions even before the machine getting into the mechanical noises and other things. So vibration, thermography, which is more like the heat and other things, and then the motor speed and the testing, right? So those kind of things that should help us to understand. So measuring the vibration level, temperature level, as well as temperature or heat generated by that, as well as the motor speed and conditions, help us to understand what could happen very soon, which can result in the mechanical failure of the equipments. So vibration thermography is a key parameters that we should measure it to prevent the failure. Okay, to prevent into the failure, right? And even before that, how do we do that, right? Even before vibration, is there any way we can understand this? Yes, of course, there are, depending upon the machineries, it's obviously vary from machine to machine. There could be a way to understand the oil level of the machine. There could be a way to understand the ultrasonic based method to identify the micro level changes happening in the machine level. And those changes will be detected earlier than the vibration itself is happening. So those kind of parameters can be measured, which are obviously expensive deployment to apply that oil level change, oil condition level, or oil level of oil that being used in the machineries. And also ultrasonic models are all a little bit expensive compared to vibrational things. So we can go from the right side to left side, from reactive way of handling the emissions to identify the emission failures, to the more proactive and predictive way of identifying that with using various techniques, right? Various technologies or sensing capabilities that are available in the market. But to increase the precision of the health, right? So based on this condition, right, the machine could start from a new machine will just start running properly, and then slowly it will start creating some kind of micro level indication that could result in a major vibration, and the vibration could result in heat generated by the machine, that could result in a noise or the smell created by the machine, and that resulted in mechanical or electrical failure. So there is a way, step by step, we can understand that. So this curve help us to apply different techniques that we can apply at the different machineries based on the criticality of the machineries, based on the cost that we can adapt, and how we can prevent it. Obviously, we have certain recommendation. At the end of the presentation, I will talk about this recommendation on how do we approach this. But generally, this is a good pattern for us to understand how the PF curve works and how the various way we can measure the machine conditions. Okay, so we talked about various ways to measure the machine conditions, right? So obviously, from the to approach that, right, we need to understand different analysis of the data, right? So the data has to be measured. What kind of data we can measure it? So we have listed down around 8 different type of data that can be measured. So one is from the vibration analysis, so from vibration level to oil level, energy level, the electrical energy consumption, and then the ultrasonic thermography mode, and fume level, right? So all of them different way to measure it. So different sensors has to be deployed to measure the various parameters, and those parameters are used by comparing each other to arrive the value. So especially vibration analysis itself is a huge topic to discuss. One webinar is not sufficient to discuss just the vibration data analysis, which we probably will conduct another webinar exclusively for the vibration data analysis using our platform. But today, generally, what we should understand that is the most and easiest way to measure the asset condition is by deploying vibration sensors or the equipment. If the equipment already providing the vibration information, that is well and good. If don't have that information in the equipment level, in the control level, maybe we should deploy the vibration sensor to measure it. And then the energy usage, second one. Third one is the heat created by the machines. The heat level of heat that being created by the machines, also a significant indicator for us to understand the condition of the machineries. So using that, we can at least identify the current condition of the machines, even though the predictive measurement need little more analysis, but at least the basic condition level of the machines, we can measure it with the help of the 3 basic data analysis that happens through with the help of sensors. Okay, so this is again critical point, right? So how do we deploy the sensors? Okay, so deploy the sensors is there, but the data is there in the remote places. Obviously, oil and gas industry, all machineries are deployed in remote places, well deep in the sea, in the seashore, and onshore, and then in the middle of the country. So there are different level that equipments are deployed on different remote places. So obviously, measuring the data at the either vibration data or the temperature data, the machine usage data, whatever we gather, that has to be centralized. That has to be centralized for comparison. That has to be centralized. The data has to be centralized for analysis, and visually understand how the activities are happening and the how the health of the machines, right? But to bring them to the central location, which obviously with the modern technology like a cloud computing, right, we can bring that to the cloud. But how do we bring that to the cloud? So that's where the industrial IoT playing a role, as sensors are connected with the cloud through routers or our IoT devices, and those can send the data to the cloud. So this cloud can be a data gathering environment or data consolidation environment with the help of IoT solutions. So IoT can be deployed in the remote places with the help of cellular network or wireless network, and those wireless network help us to help the machines to send the data to the cloud through this process. So not just that, the industrial IoT also comes with some level of analytics, inbuilt analytics. We can compare the data, we can visualize the data and things like that. But to understand the asset condition of that, right? To understand the asset condition, so to understand the asset condition, we need to have little more analysis data. Analysis has to be conducted. Okay. So now in the oil and gas industry, right? So what are different type of missions, and basically to understand a little more on the sensors and actuators, what are different type of missions are there and how we can understand that. We talked about the 3 different level, right? Upstream, and then we have talked about the midstream and downstream, right? So in the field level, right? So there are pumping stations which obviously maintain the pressure of the gas and oil, which are made as a mechanical parts that piston goes ups and down to to create a to maintain the pressure on the field, on the pipelines. So those stations, right, also called as pumping pits, and those things creating a lot of activities are there, movements are there. Like you can see in the left side, horse head move, that basically move ups and downs to maintain the pressure and pumping the level to the oil to the next level in the flow of the midstream. So so there could be a lot of moving parts, and those parts are creating a lot of vibrations on that, right? So obviously we can we can measure the vibration. There is a gearbox on that. We can apply we can connect with the vibration sensor on the gearbox to understand how the gearbox is performing in a different condition, different climate conditions, different wind conditions, how this whole equipment is operating. Also so based on the pressure on the pipelines, how the vibrations are creating a different set of parameters. We can measure all of them. The speed of the motor that attached with the gearbox, right? And we can measure the speed of the motor. Whether the horse head is moving ups and downs, we can also measure it with the level sensors. So so different level of sensors we can apply that to measure it, different data sets, to understand how the whole equipment or the machineries are working on the remote field. Second one is the pumping stations. The pumping stations, using motors and pumping motors and filters, and there are a lot of pressure is being maintained on the pumping stations, which are basically electrically powered with the motors based model to reduce certain level of gas or oil pumping. So those stations also generate vibrations because motors are there, which are obviously generate a vibration. The motor speed, the speed of the motor, the vibration level created by the motor also indicates the pressure being maintained on that, and also an indicator that there is something change is happening on the field, which is triggering the motor to create more vibrations. The current flow of that, right, the energy consumption of those motors also could be an indicator to understand how much power consumption is happening over the period of time. So it's gradually, step by step, if the problem is increasing step by step or gradually over the period, we can understand how the problem incrementally increased and then might lead into a machine failures. The pressure of the pipelines, right, the pressure of the pipeline or the leakage level, also an indicator for us to measure if there is any leakage is happening, which can prevent it with the help of alerts triggered by the machineries. So these alerts can help us to act on the leakage or any pipeline pressure changes that could significantly creating a major accident on the pipelines. So which can also be prevented with the help of these sensors and IoT platforms. Now, how do we do that? Just to understand a little more deeper, how we can send the data to that. So there are multiple ways to do that, but generally the sensors are retrofit sensors that are deployed on the attached with the machineries that are deployed on the remote field. Now the next step is to understand how the data can be captured locally, right? The data can be captured with the help of IoT gateway, which can connect to the sensors and pull the data out, and then those data can be formatted, structured before they send to the cloud. So these IoT gateways are kind of wireless routers, and they can make a communication to the cloud through internet and or through wireless network, either through cellular or other wireless network such as LoRa or NB-IoT or anything else, right? So whatever depends upon the field that we are deploying it and the coverage availability there. They can connect to the internet and then send the data to the cloud. The cloud receive the data and process the data, and is filtering the data based on the rules defined by the operator, and those data are identified as a solid proof of data for understanding the asset condition. And those data are sent to the data analytics platform or some kind of a data analysis tools that help us to understand how the data can be visually presented and how the data can be compared to arrive it, such as comparing the vibration and the temperature, right? The more vibration, it could probably create more temperature on the machineries because the machine getting heated because of the vibration and frictions on that. So it could be combination of that. So combining two parameters to understand how these parameters can be compared and understand what could be causing. Suppose the vibration is not that significant, but only the temperature is increasing, then obviously though there is something else is triggering the machine to get heated, which may not be related to the mechanical problem, but may be related to the electrical problem, right? So so that way we can identify that even before we go to the field and then checking the machineries physically. We can understand more and more information through such data that we gather with that. And all this data, right, are helping us to understand the condition of the machines at various level, right, from the level that it started functioning as a new machine to over the period how that the machine usage and performance trend has been changing, and that's indicating the health of the machine. So to apply this whole process, right? So as I talked about in the beginning, this is a process. This is a process. Is not like one time go and install it and then yeah, it's sending some data, I'm seeing data. What is the action that we are going to do with the data? So the strategy, right, for applying this process has to be defined well to reach maturity level. So we call it as a maturity, time versus maturity, because the time duration it takes to reach the maturity, the more time, the more data that we gather at the different interval help us to reach the different level of maturity on the maintenance activities, right? So let's start from the basic, right? Today, whatever is in practice, right? The practice today, 100% all oil and gas companies or other machinery based operation companies are managing it based on the preventive models. Means that they looked at the problem, they see the problem, they go and fix it, or they schedule it as a monthly once, go and change oil, go and change the belt, go and change the loosen nuts and bolts, tighten it. So it's based on that. Okay. So it's more on preventive, right? Which obviously increase the cost. They're all like a low level maturity, right? Because you are always putting cost and effort to manage and reacting to that. So it is all driven by the schedules. It's all based on the calendar, driven by the schedules and other things, right? So what you are seeing in the horizontal, right? The horizontal is the technology, and then vertically, vertically what you are seeing is the technology, and then horizontally what you are seeing is the driving force of that. So the next level is the condition based. We are talking about condition based model because basically this is the next level that you can step in. before you get into the other level of maturity. Condition based monitoring is based on the health of the machines, right? We are measuring the parameter of their machine. We know that the machine is operating at this particular vibration. We know that machine is always operating at this particular temperature, and sudden increase in happening on the machinery, we can identify that, and then that can indicate us, oh, there is something is not good in the health of the machineries. And based on the parameters that we are measuring, we can also come to a conclusion on what could be wrong on the machines. So that is a condition based maintenance. Basically the condition of the maintenance, it's not like schedule based. So only if the problem is happening or indication is coming before the problem happens, that is going to help us to monitor and then go and act on the maintenance activities. So condition based maintenance are handled at the next level. But for that we need the sensors and IoT, right, to collect the data and analyze the data. But the next level is the prediction based model. In the prediction based model, based on the history of the conditions and how the machine is behaving, two key things that we need to measure it. One is the health of the data, machine data, that basically, like, the vibration level, the temperature level, the oil level, all of them. And also based on the patterns. The patterns in the sense, like, how this trend is there, right? If every maintenance activity, based on the maintenance activity, how much time it takes to create a vibration again to the extreme conditions, how much duration it takes that. So based on the pattern of the maintenance as well as the machine condition, is defined that, okay, periodically this machine, even regardless of the maintenance activity, this machine could create a problem at 45 days once or 60 days once, depending upon the machines. We can identify that, and that is more like a predictive model, which help us to foresee the maintenance activity coming on the upcoming months on a different machines. That also help us to plan the maintenance activity properly and execute the maintenance activity well ahead of time, instead of handling material problems and the other problems in the maintenance aspect of that. The next level is the intelligence based model. Means that not just the prediction, right, not just the prediction, but also it's indicating that which part could be changed, or which part required replacement, what is the lifetime of the parts, right, in the machines, and what is the duration of the each component that we are changing, how frequently we spend on the maintenance activities. Those intelligence information can be gathered with other parameters, right, not just a maintenance activity, but also the frequency, the model, the part model, the parts that we are maintaining it, the OEM vendors, the definitions. So based on other inputs from the field, right, not just the machine health data, other inputs also adding into the conclusion or analysis, and then arriving a intelligent information that could result in, even before the prediction, right, that could result in even better response to those maintenance activities or machine condition monitoring. And then finally we reach the level where it's a constant growth, constant running machines, and those machines are always defect free, 100% defect free while they are operating, like airplanes, right? So they are all highly maintained machineries, and there is never failure on the fly, right? So it's always 100% success on that. So these are all based on that conditions that we can arrive even in the machineries that we operate on the oil field. So to arrive the maturity, right, we have to go a step by step from the current state to the state where we are going to have the condition and then prediction and intelligence to arrive that. And we need to go as a process. This takes time. It's not like that's why it's called as a process. It's not a one-time event. So to arrive the predictive maintenance, you have to have the condition data in place to arrive the predictions. So predictive maintenance is not something you can achieve it just like tomorrow, and it has to have a data ready for you to do the predictions over the period. And for that, we need to first adopt the condition based monitoring and then reacting to that based on the conditions. So we are coming here in this area where we are providing a comprehensive platform. So Fogwing is our industrial IoT platform. Obviously, it helps us to connect to the devices that we deployed on the remote places, on the machineries, and try to collect the data from the sensors and then putting that into the aggregation. So Fogwing is more like a device management, connectivity and data aggregation, asset data aggregation platform. And it helps us to consolidate all the data that we receive from the machineries from the oil field. And then these data are pushed into our upcoming our new platform. We usually have Analytics Studio, which is obviously you can do the same thing in Analytics Studio, but we have explicitly made a newer product for asset-based condition monitoring with more parameters and metrics. So obviously the data can be sent to our Asset Plus system, which can apply different metrics to come up with the health index of the machineries, and those health index will shown to the management for reporting. Not only that, the field engineers also can provide input based on the field conditions. They can also provide input based on the maintenance activity that they do on the machineries, not just the machine data, but also the field engineer data that can be consolidated in the platform, in the Asset Plus solution. And then that will help us to arrive the frequency of maintenance activity and the condition of the machineries. By combination of that, you can have a better insights into how the machines are operating on the remote field, and that gives a significant input for the management and supervisor to decide on how and when they have to act on certain maintenance activities on those machineries. So we provide both platform from data aggregation standpoint, and then the asset condition monitoring aspect and the related metrics aspect of that. So one of the two key components that is required to basically start measuring the conditions of the machine, or also we call it as a asset health meters. These meters are based on the parameters. You may have electrical consumption, you may have a frequency data, you may have different parameters that you are receiving from the machineries. You may see the raw data, or you may see the trend of the data as well. Also, you can compare that information with your maintenance log, because the maintenance log also maintained in the same platform, in our Asset Plus platform, where you can compare it to what maintenance activities you are doing and what is the result of that. By doing this maintenance, what is my machine performance health condition? The health indicators will help you to understand by doing this maintenance activity how my health indicator showing the healthiness of the machineries. If the result is not coming, then probably we need to look at what we have done as a maintenance. So there is a correlation between what maintenance we are doing and what is the system is generating data, or the machine is generating data, right? We need to compare that. The correlation of this data can be visually seen by comparing the data in the platform. So we have we are having a separate demo session planned later this month, where we will show the complete demo of this product with all the data that we can create it as soon as we are launching in next few days. Now, so in terms of the best practices, right? So because we talked about initially, right? So it's a process. We know that asset condition monitoring is a process. We know that we need to start with a smaller scale. We can measure it over the maturity. But what is it? Where do we start it? How do we implement it, right? Today I have machineries. How do I start it? The very basic thing that we recommend to anyone who's starting a new initiative using asset condition monitoring based solution, or they're looking for such solution, they should start with simply by going with the 2 or 3 parameters, the basic parameters that they can measure it today, with the smallest amount of investment on the sensors and on hardware components, putting together, and then start collecting the data, such as vibration and temperature, which is a very, very basic and commonly applied to all machineries that we have seen in the oil field. So vibration and temperature is a very, very basic data that we should gather it. So deploy the sensors. If the equipment does not have the controls that providing the data, then obviously go for external data sensors that fit into the machineries and start measuring the vibrations. So measure the vibrations, send it to the cloud, and start analyze the data to understand what is my machine's current trend of that. You may not know that when your machine is already deployed over the years, right? Now you are attaching the sensors. Obviously you don't know what is the precondition of the machines. So definitely you should understand what is the precondition of the machines, right? To understand the precondition of the machine, you need to start measuring and seeing the trend of that. So you need to look at the data over the period before you take into the next level of prediction and other things, right? So first you need to take it, and while doing this, you don't stop the maintenance activity. Maintenance activity should continue to do that for a period of time, probably around 3 to 6 months time, depends on the frequency of the data that is coming from the machine arrays. You need to have the maintenance also carried parallelly. So because of that, you could start seeing some kind of a patterns arrived by the data. So these patterns and trends arrived from the data will indicate, what is your mission's total uptime, what is the maintenance activity happening on the missions, and how frequently the maintenance activities are happening on the missions, and what is the condition of that missions over the period of time. That help you to identify the baseline health index of the missions. You have to arrive the baseline health index of the mission before you talk about the predictive models or predictive maintenance based models, or going to the next level of maintenance activity, or even reducing the maintenance activity. You need to understand the baseline. Once you define the baseline, right, then you slowly start reducing the preventive maintenance, which means that your calendar based maintenance, right, you slowly reduce it. Instead of, let's take monthly once, you may try to do that like 45 days once. And then when you're trying to reduce the maintenance activity, you could also see the trend of the mission, how the mission is changing. If reducing the maintenance activity is increasing the vibration, that probably you need to roll it back and then do that. So you need to try that out to see how you can reduce the maintenance and what could be the result of that maintenance in the mission areas, whether the machines still continue to run without any issues, or is it creating more issues. So you need to understand the threshold of the limit when you can avoid the maintenance. Instead of doing monthly once maintenance, you may put it in a 45 days once maintenance. That may result in reducing the overall cost of the particular year, right? Instead of monthly 12 times you got to do that. If you put it 45 days, probably you can do it in 6 times or 8 times. So 8 times maintenance activities, that will reduce the cost for you. So basically you need to understand the frequency and then play around with that to see whether doing the preventive maintenance at a different frequency is not impacting the machine performance. And obviously I understand the threshold where you must do the maintenance activity. Once you arrive that, based on this pattern and understand and trends, then you go to the next step of how do I do the predictions on that. Based on this trends data, do the predictions and understand how, when and where I can do a maintenance. So it depends on the missions, right? It depends on the mission, how long the mission is running in a day, how much time it's running in a day, how long the pressure is maintained in the missions, how much volume of productivity the machine is created, the power consumption, the environment conditions, like harsh winter conditions, it might create a different parameters and values than the summer conditions, right? So it depends upon the climate conditions also, it might vary. So we need to understand the entire year on how the machines are running to arrive at predictions. Then only your prediction will be more accurate. Otherwise your prediction will not be accurate at all if you are trying to do only with a few set of data, or day one you are trying to go for predictive maintenance based model, which is not going to give any result until you understand the baseline of your missions conditions. And that's what we call it as a asset reliability maturity. That maturity level you need to understand before you go for that. And obviously when in the journey of the supply solution, you can also understand how it can be simplified. And the investment also can be a smaller investment in the beginning, and slowly as you prove the model, you can add more sensors and scaling up more parameters, so that you have better visibility, better control, better maintenance activities over the period, instead of putting all the investment in upfront and seeing a failure on the preventions. So as we talked in the beginning, we are explicitly coming with the product for asset condition monitoring, Fogwing Asset Plus. You can still use our existing Fogwing IoT platform and our Analytics Studio. Analytics Studio is more like a data analytics studio. You can still use that, but if you want the explicit asset-based data and you wanted to grouping together in a different way, and you can still use the Asset Plus solution, but also it comes with additional metrics, comparative metrics and health index, which you may not see in our Analytics Studio, but you can see it in Asset Plus platform. So Fogwing Asset Plus platform comes with all-in-one bundle. So you can get the hardware, the IoT gateways from us, and that comes with a dedicated instance. And then you can configure your sensors. We provide the sensors support as well. And remote configuration support, all of them we are providing as a single package. But if you want to know, if you want to see the demo of this particular product, you can reach our team at sales@factnode.com. So we can help you to, we'll show you the demo, and then we can help you to see the results there. With that, I can give back to Abhishek, to you.
Thank you, Hari. Thank you for the insightful session on asset condition monitoring. So now we can move on to the Q&A session. So Hari, we have a couple of questions already from the audience. So I'll shoot one onto you. How accurately can we identify the downtime with an asset condition monitoring system?
Oh, so we have data rules. We have a process called data rules process, asset condition data rules. These rules can be defined by the user. Let's take, you wanted to consider even before the machine goes down, means completely machine shut down, right? You want to understand that the machine is going to shut down. So either you may go for significant vibration level down, or you may think about, significant vibration level up, depends upon the machine or the electrical consumption level. You may understand, you need to understand the threshold of that, or that where the event before it's going to the failure. So you need to understand that and set it as a data rule. As soon as the machine reaching that condition or reaching that level, right, then it will trigger the alert to you, and then you can, even before the machine goes down, it can send alert to you, and then you can look at that. Based on the alert, you can come and look at the data and understand what is happening in the machine levels. So this can be done in the platform side. We are providing that feature as well. But however, you have to, as I said earlier, you have to identify the pattern. So you have to understand, when the machine will go to failure. What is the minimum level I can put it as a threshold, so that the machine, before machine goes down, it can trigger the alert to me. So based on your input, the system is going to trigger the alert, right? So obviously you have a better control on that, but you have to understand that before you set the parameters.
Okay, so over to the next question. What happens if the sensors sending the data about the health of the assets to the IoT platform fail? How do we know that the sensor themselves have failed?
Oh, okay. So that's a good question. So we have a way to identify that whether the data is coming from the system. So either the sensor is failing, or the connectivity itself is failing, right? Both way, we have in our Fogwing IoT platform, there is a way to identify that. So we have an inbuilt feature called downtime alert, and our machine device down alert. So these are device unavailability alert. So this information, this flag will help you to understand whether the sensor is down. There is a multiple way to achieve it. One is, your sensors may set it as a 0 value, or your device is not sending any data. Your sensor's values are not coming at all, but your device is constantly connected to our platform. So you may create a sensor values as 0 in using our formula function, which is inside our Fogwing IoT platform. That help you to understand that your sensors are failed. If your connectivity itself is failed, then obviously we have a simple way, just a one-click flag that help you to get the alert that the connectivity itself is failed, which means that your the devices that deployed on the remote field is not able to connect to the cloud and not able to send the data to the cloud. And that heartbeat, we are measuring it, and then we are triggering the alert on that. So there are multiple ways to achieve that use case.
Thank you, Hari. To the other question, are there appropriate sensors available as of now for every type of attribute of the assets, like temperature, vibrations, and numerous other characteristics of the assets? If available,
Yes,
well and good. If not, what is the workaround?
Okay, so there are sensors available, especially the sensor that we talked about today, right? The vibrations and temperature, ultrasonic sensors. There are plenty of sensors available in the market, and each sensor has a different way of modeling it. MEMS sensors are more of axle-based sensors. So there are different type of sensors out there. Depending upon your mission, depending upon your use cases, you may pick and choose the right sensor, or you may just go with the MEMS sensor, but it obviously may not give 100% accurate, but it will give some level of accuracy on the data. So basic sensors are absolutely available. Okay. The other way to do that is, if the controller, the mission provider, right, the OEM vendor who provided the controllers, and the controller already measuring that data with the help of internal components, then well and good, you don't need the sensors. You can just take the data from the controls, and then you can send it to the to our platform. So that way, you have all the data in our platforms, obviously.
Okay, another question. Is Fogwing Asset Plus meant only for oil and gas or for any other manufacturing industry as well?
Oh, this is very well applied to all manufacturing industry, not just for oil and gas. Today we are talking about oil and gas because that's they are the more significant benefiter of this particular solution. But obviously, anyone who is deploying machineries on the remote places, anyone who's looking for any manufacturer who's looking for conditions monitoring because of the criticality of the machines, they can adapt Asset Plus. The product will support any conditions. We don't have anything restricted to the asset oil and gas alone. Yeah, anyone can use that.
Okay, so Hari, one more question. Is not processing the data at cloud too late? Should we not process at the edge level?
Oh, yeah, that's a good question. So yeah, of course, if it is possible, we should do that at the edge level. But obviously, there is one problem is there, right? Because initially we talked about centralizing this, right? Because it's in oil and gas, if you take it, all are remote field, and nobody is going to sit in the edge level and watching that, right? Obviously, the engineers are field engineers are going to be on the traveling from place to place. The administration is going to be in remote place. Not everybody is going to sit in every missions next to the mission. So even though we deploy the edge, there still need to be a communication that comes to the cloud and then send the data to the using the data to do the alert. Then only the data can be visually seen by the operator or administration, right? So the data volume can be reduced with the help of edge that we deploy on the field. The edge will process the data, understand the health index, and send the health index to the cloud, and that can be presented to the management or the administration. But obviously, the data has to come to the cloud if they need a centralized access to the data.
Thank you, Hari, for answering the question. So that were all the questions. Okay, one more questions I have got just now. So a combination of edge and cloud is good, right?
Yes. Combination of edge and cloud is a good value, but obviously it is going to increase the cost. Okay, it's going to increase the cost of implementation. Now, if you have you need to come when you are proposing this kind of model to business, right? We need to look at that. What is our current maintenance operating cost, and by deploying this solution, how much the cost can be reduced. There is it should not create a problem, or it should not indicate that there are more than maintenance cost we are investing on just for monitoring, right? Obviously it will not fly out, and then the ROI will be significantly impacted, and that could result in project failure. So we need to look at that, whether is it really necessary for edge on the field. What is our current operating cost? What is our cost of managing maintenance activities? And just deploying a sensors and the cloud computing, we can solve this problem, which is reducing the cost. Obviously, edge will increase the cost. So, or do we really need it, edge? There are other scenarios where if you have a cluster of machineries, like you have 20-25 machineries in a same place, and you need to measure all the machineries. And for that purpose, maybe you can set up an edge on that, because the cost will reduce by sending all the data to the cloud. So you can collect all 20-25 machineries data into the edge locally, process it, and then send only the filtered data to the cloud. So obviously, you can see the value of that edge deployment, because you are trying to cover that. But if it is only one missions or two missions, right, and then you are trying to put the edge for that, then what will happen is the machine maintenance cost is lower than the edge cost. Then obviously that project will not fly, and that will result in failure only. So we need to take a call based on the setup and based on the number of missionaries that we need to consolidate in one single place, and then process it on the cloud.
Thank you, Hari. Okay, one more question. Can the defect-free stage, that is the fifth step, be ever reached?
Yes, it can be reached. Not like it is impossible, but obviously that required a significant process adoption at the employee level, especially field engineer level, to the top level. It requires significant uniformity and discipline to achieve that level of maturity. Obviously, if you look at that, the flight companies, right, they're all reaching that, right? So they're all ultimately, but that requires significant change in the whole organization process. It depends on the organization, how the organization can adopt this kind of a process. Usually it is very tough for a traditional manufacturing setup to get into that level of maturity, but it is possible.
Okay, thank you, Hari. So guys, any more questions? I think it's almost time to wind up the webinar session. So guys, if you have any questions, you can post that question in the comment section of the video that will be uploaded in the YouTube channel.
Thank you so much, everyone. Thanks for joining this webinar. As we said earlier, this webinar will be available on your YouTube channel. So if you missed out this webinar, or you wanted to see, watch this again, you can go to our YouTube channel and you can see not only this webinar, you can also see other webinars, other demos that we have done in the past. You can see all the materials there, and click on subscribe on the YouTube channel so that you get notified whenever we upload a new videos in our channel. Thank you so much for joining this webinar, and have a great day.
Thank you guys. Thank you for joining the webinar. Have a nice day.